Okay, my people, in today's class, our subject for today is we are dealing with physics today. Today we are dealing with physics, and then our topic for today is mechanics. Mechanics. Remember, when we are talking about mechanics, that is, we are dealing with motions either at statics point or at dynamics. That's when we are talking about statics. It means motion at rest. The dynamics, that is motion that is not at rest. That means they are moving at all instants. They are moving at all instants. So now, let's look at this question. The question says a particle is moving. That means it is moving. That means dynamics. That means this particle has to be dynamics. So a particle is moving along the x-axis such that its position is given as. That means this is the equation. That is the distance or displacement. X equals to 4t squared minus 16t plus 12. Yeah, we have been given the equation. So what do we do? Remove the equation. Solution. Our particle is x equals to 4t squared minus 16t plus 12. And in the equation, we have to find the instantaneous velocity. When t equals to what? 5 seconds. Instantaneous velocity when t is equals to 5 seconds. At the same time, 2. Find the instantaneous acceleration when t equals to what? 5 seconds. Then 3. At what time is the particle stationary? That means at what time is the particle remain at rest? That is stationary. That means as I was saying that mechanics has to do what? Dynamics and statistics. So if you look at the last part, they are telling you that at what part, at what state is the particle at rest? Whereas in this one, they say instantaneous velocity. That means it was moving. Acceleration, it was still moving. So it changes. So now at this point, they ask you when it at rest. So now, let's see. Remember, when I'm talking of instantaneous velocity, what do I mean? I mean differentiate time. Differentiate distance or displacement. When I'm talking of instantaneous velocity, it means this order derivative. So now, what do you do? Instantaneous velocity, v instance. V instance. Remember, velocity is what? Velocity is what? Displacement all over time. So now, because I'm talking of derivative, that will change in displacement or change in distance with respect to change in time. So then I will relate this down in terms of x all over what? Dt. Because our motion here is x in terms of t. That's why you see x all over dt. But x equals to what? But x equals to 4t squared minus 16t plus what? 12. So from here, I will quickly say that d into 4t squared minus 16t plus 12 all over what? dt. So what do I do? I'm differentiating what's inside the respect to what? So now if I differentiate 4t squared, remember, integration, what do we do? We add 1 to the power. Then when we add to the power, use the power to divide 2. And then this one now, differentiation. That means reciprocal of integration. What do I do? I'll use the power to multiply. Then subtract 1 from the power. Because remember, integration, add 1 to the power, then use the power to divide 2. Then differentiation now, I'll use the power to multiply, then subtract 1 from the power. So now if I do that, I'll put this power, that is 2 times 4, this power, then t, and this power, I'll now subtract 1 minus 1. I'll subtract 1 from the power, then minus this one. The power here is 1. So that will be 1 times 16, 1 times 16, t, then 1 minus 1. Then this one, the power here is what? 0. Power there is 0. So what do I do? I will say plus 12 times 0 minus 1. Then when I say from there go to plus, then 0 times 12. 0 times 12. Raise the power 0 minus 1. So now from there, 2 times 4. is 8. So our v instance equals to 8t, because there is a 2 minus 1 is 1. So t raised to the power 1 is 2. So minus 1 minus 1 is 0. Anything raised to the power 0 is 1. 1 times 16, here is 16. 0 times 4, that's this one is 4. Here is 0. That one is 1. That one is 1. So now we have that v instant is what? 8t minus 16. So now v instant, that is instantaneous velocity when t equals to what? 5 seconds. So at t equals to 5, I will find my velocity. So here at t equals to 5 seconds, velocity, that is v instant, equals to 8t minus what? 16. That is v instant will be equals to 8 of 5 minus what? 16. Because our t is equal to what? 5 seconds. So now what do I do? 5 times 8. So velocity equals to, here will be 40 minus what? 16. 8 times 5 is 40. V instant 40 minus 16. Velocity. Please, we do simple calculation here. If you don't know what to do, just this is 40, this is 16. You subtract. And if you said this man minus this man cannot come. So what do? Borrow 1 from this man, add to this man. This man is 10. So when you say 10 minus this, you will be 4. Then how many students here? Remember, you borrow 1 here. That means here is 10. 3 minus this is what? So that means at this point now, what do you have? We have that our velocity is what? 24 meter a second. That's our velocity. That's our instantaneous velocity. 24 meter a second. And so now, for our instantaneous velocity, what does instantaneous velocity mean? That is a instance equals to what? Remember, acceleration is what? Change in velocity in respect to time. So now, that will be dv all over what? dt. dv all over what? dt. Remember, our v is what? But v equals to what? 8t minus what? 16. So there 3. Our a instance will be now equals to d into 8t minus what? 16 divided by what? dt. So from here, you differentiate. That is second derivative. dv differentiate this respect to time. So now our a instance will now be equals to, remember, apply the same method. If I differentiate this, remember, subtract 1 from the power. They use the power to multiply. So if I differentiate 8t, our will now be equals to, remember, apply the same method. If I differentiate this, remember, subtract 1 from the power. They use the power to multiply. So if I differentiate 8t, our 8. Here is a constant. If I differentiate, it is 0. So now, that means our instantaneous velocity is 8. And then, finding instantaneous acceleration when t equals to 5. So when t equals to 5. So now, at t equals to 5 seconds, our a instance, our instantaneous acceleration equals to what? 8 meters per second. Please, because there's no velocity of t, that means at 5 seconds, it travels for how many distance? 8 meters per second. That's our acceleration. And it does not mean that you must see this guy. There's no t here. So that's that value that you have there. That means at 5 seconds, this will change. So the last question says, at what time is the particle stationary? At what time is the particle stationary? I told you earlier that when I say stationary, it means a body at rest. That means that body is not moving. That particle is not moving. When we are talking about movement, that is displacement or distance. And this man These are displacement x, distance. You are looking for time. You are looking for time. These are the time. You are looking for time. So what do you do? Bring this question. Let's take this question. At what time is the particle stationary? We have that x equals to 4t squared minus 16t plus what? 12. So now, at what time is the particle stationary? Yes, for it, I told you earlier, when a body is at stationary state, that means it's not moving. At that point, it's at rest. When we are talking about rest, it means it is zero. It means zero. When you hear of the word stationary, it means zero. So that means this x now is zero. So now x now here will be 0 equals to 4t squared minus 16t plus what? 12. And if you look at this question, this is a quadratic equation. Remember that in our first class we started with quadratic equation. So now solving this. So now they said at what time is the particle stationary? And my people, this is the particle. The particle says s equals to 4t squared minus 16t plus what? 12. They say stationary. I did it earlier. Once I say particle is stationary, and then that means it's what is at rest. Then when it is at rest, remember that particular particle is 0. So now that means our s is what? 0. 0 equals to the whole of this. So remember in our first class, I can remember I bring up a topic called quadratic equation. And yes, if you look at this question, this is a quadratic equation. So now, what do you solve this? Way to solve this, reduce the coefficient of t squared to stand alone. Reduce the coefficient of t squared to stand alone. So this is what we do. I'll divide through by 4. So that will be 0 over 4 equals to 4t squared over 4 minus 16t over 4 plus 12 over 4. So this one will cancel. This will reduce of this one, I have 4. This will reduce, I have 10. This one is 0 divided by this 0. So I'm having that t squared minus 4t plus 3 equals to what? 0. This is a quadratic equation. I've been able to reduce the coefficient of t squared at this point. The coefficient of t squared is what? 1. That of t is 4. And that of here is constant. Remember, constant is 10. So now, what did you do? Remember, I told you earlier, the trick in solving quadratic equation is that, remember, look for a value such that if you multiply, you have 10. Then if you add, you have this man. So now, let's do that. And if you look at this man is 3. It's plus 3. So now, if I say 3 times 1, that will be equal to what? 3. Plus 3. Because here is plus. I want to get minus 4. How do I get minus 4? At the same time, if I say minus 3 minus 1, that will be equal to what? Minus 4. And then remember, if I also say minus 3 times minus 1 is what? Plus 4. So that means factors of 3 and 4 is minus 3 minus 1. So let me quickly substitute this man inside this man. So if I do that, this is what I have. So I have t squared minus, remember, factors. These are the factors. Factors is minus 3 minus 1. So that will be t squared minus 3. Remember, you always multiply because here is t. You always multiply t in each of those factors. So that will be minus 3 times t. That will give you minus 3t. Here is minus. I'll say minus 1 times t. That will give you t minus t. Plus 3 equals to what? 0. I can introduce my bracket. So now what do? I look at this side, the left hand side. I can factorize. T is common here. So what do I factor t out? So that will be t into. If I remove 1 t, here is t squared. So if I remove 1 outside, that will be t. Here t is left. Minus, here is 1. So if I factor out, here will be what? 3. Minus here. Here is nothing is common here. but I can factor out 1. If I factor out 1, that will be minus 1 into t plus 3 equals to what? 0. My people, this and what we have here is that we are having that this man and this man, they are not the same. Based on for the fact that they are not the same. I think minus 3 plus 3. That means our factors is t minus 3 into t minus 1 into t plus 3. All equals to what? 0. Look at here. This man and this man. Look at this man, this man. So now for you to find the value of t at when the particle is stationary, that means we simply equate each of these terms to 0. So if I do that, I will say t minus 3 equals to 0. At this point now, when I cross this guy over it means that t equals to what? Plus 3 seconds. That is when the particle is stationary. And then at the same time, t minus 1 equals to 0. If I cross this guy over, that means t equals to what? Plus 1 second. That is still when the particle is stationary. Then at the same time, if I say t plus 3 equals to 0, you can say that t equals to what? Minus 3 seconds. But my people, remember, there's no negative in time. Remember, there's no negative in time. So that means this man will be cancelled out. This man is cancelled out. There's no negative in time. Time does not count negative. It counts only positive. So that means our particle is stationary when t equals to 3 and 1. Thank you very much. Stay informed. In our next class and discuss more about mechanics. We will discuss more about mechanics, and then at that moment we might look at more of stationary questions. Thank you very much.